we'll complete our this board class. So after this mask, basically I'll create before this mask, and after this initializer, let's create our update that will be updating our bird position. So let's create that is update function, and this update function will obviously take our self and delta frames. So what is this delta frame? So it will be default value is 1. So this delta frame argument is a number of frame elapsed since this method was last called. So this is basically a number of frame elapsed. So let me just comment it out here so you can read it properly. So this delta frame is number of frames elapsed, and this frame is elapsed since the method was called. Basically this update method is called, and we have something that is this update function. So let me see how this update function will be just to work. So basically what will be the working principle of this update function. So this function will just basically use the cosine function. So we'll just implement here cosine function, and it will be used cosine function to achieve something that is the smooth curve or smooth climb, you can say a climb. So as to get the smooth climb, not a rough climb, we'll just implement as a cosine function. So in the first and the last few frame, basically the bird will climb very little, and in the middle of the climb it will climb a lot. That means if you have here basically in the few frame, that will be in the last and the first few frame, the bird climb will be very little. So that will achieve from this cosine function, so is to give our bird a smooth climb. So let's give that position to update this, basically the position of our function. So for that, what we're gonna do first is we'll check if self dot second to climb is greater than 0. So this is basically if it is greater than 0, bird millisecond to climb will automatically decrease. So as to make it decrease, what we're gonna say is fraction. Let me just define another here a variable, that is a fraction climb done. So this is not a complete, there will be only the fraction climb. That would be 1 minus obviously, and self this millisecond to climb divided by bird, and dot what you're gonna have is climb duration. So I've said you before that is a climb duration here was while creating this basically a bird class. I've said you this is the number of millisecond it takes the bird to execute a complete climb. So this is the time for the complete climb, and this is basically a millisecond to climb is basically to see if it automatically if it is greater than 0, this will be automatically decrease, and this is basically a fraction climb. That is 1 minus this value divided by the complete it will take to just climb basically. So this is a fraction climb which has been done by the bird. Now what we're gonna do is self dot y. So where is the x basically? So let me tell you where the x gone. So let me just decrease here first. So change will be only the y coordinate, because the x coordinate there will be no movement like this movement. So bird will not move in this, bird will move either up or down, bird will not move either left or right. So we'll just stick to here a y position, the y coordinate basically. So I'll say bird, just give the bird instances here, that is the bird class, and with this we'll just use the climb duration and not climb duration, maybe it should be climb speed here. So climb speed, and just multiply it by frame to millisecond, and frame to millisecond will just take us a delta. So this is important, delta frame. So delta frame was basically a number of frame elapsed. So this is our basically the self dot y position to move up and down, and frame to millisecond is to convert from that images we got. Basically you can see here what is doing this frame to millisecond, that is converting to millisecond with this rate basically, that is your PS rate. And what we're gonna do here after this, we have here delta frame. Now again we have to multiply it with basically our function, that is 1 minus math dot and I have already said you the smooth climb will be by this cos function. So I'll say cos here, cos function, and just give something inside this cos. That would be fraction, this fraction climb done obviously, and multiplied by math.py. Pi value will be 3.14, so as to give the smooth climb. So let's just close this first. So let me check it once again. So it would be like this, and this is closed here obviously. So this is only the 2 parameters. So after that rotation, or after that movement of bird in y direction, what we're gonna have next is after this basically here, and let me just see, it should be what we're gonna have now next would be, we'll just call this millisecond to climb will be decreased now. After this basically there will be movement, so that would be self dot millisecond to climb. So this millisecond to climb is something when you just create it here, that is the basically the time, which is the bird, and dot climb duration. So this was the millisecond that the bird will completely use to climb, and that would be the to achieve the complete duration, that is bird dot duration. So this should be now decreased because we have now just moved, so this should be decreased to frame dot millisecond, and just give now frame, so that would be the delta frame obviously. So after this what we're going to have, that if it is not less than greater than 0, what you're going to have, then just add it. In that case we'll just add it now, we won't decrease, rather we'll just add it now, just bird dot sync speed, because there is no basically tap, or there is no movement from the player. So that means just sync here, that will be the speed will be sync, and the bird will go downward. That means here the frame per millisecond, it should just give the delta frame for here, and we are good to go here. Let me see once again, and this is the update for the movement of our bird. So if you have any confusion here, so this basically, this is to check if it is greater than 0, then your millisecond to climb will automatically have to decrease. So if it is greater than 0, then it should be increased, else it should be decreased with this basically a sync speed. So this is the case. And similarly what we're gonna do next is we'll just quickly make our image property, and this will get a surface containing this bird image. So let's get this property now. After this update function, we'll just have something that is image function, and image will just take ourself here, and just let me say it is a property here at the rate, and just give a property here. And after this what we're gonna do, so in this self this will basically decide, so let me just comment it. So this function will decide, this will decide whether to return image, that is the image where the bird is basically, where the bird is invisible, or using the pointing upward, maybe using this the image that was the pointing upward image, or where it is pointing downward. Based on this basically it can also give this pointing upward or downward, that is the downward image. So what will be the criteria is based on the Pygame dot basically our time dot get ticks. So let me just close it here, and with the get ticks, so based on this it will just say whether to just return the image that is either this up image, pointing up image, or pointing down image. So based on this ticks value, so this image will just return that. So let's make that to return. So first we'll check if Pygame, that is not properties, Pygame dot time dot get ticks obviously, and if it is modulus, that is 500, that will be our height, complete height. So if greater than equal to 250, then we'll just return basically up, that is a returning self dot mask, and that would be wings up. And what you're gonna do, else if it is not greater or equal to 250, then just return the image that will be just pointing us self mask, and that will be wings down in this case. So let's check once again. So this is our image property. Now the next property what we're gonna have is the important property, and that will be our, just define it, and that will be the rect property. So this rect will take obviously our self and just give it here property, because it is also our property. So let me just type here property, and inside this rect what it's gonna have is this will just get the bird position, width and height as a rectangle. So we have used this rect many times, because while creating the snake in the Pygame lectures we have created this rect, that is the rectangle based on the coordinate. So just return now, that will be the just a rect, so we don't have to call from the pygame.rect. And in this rect, what it is not a small rect, it is bigger rect and with R capital, so it can give you something that is give the, for me first, the position that you want to have, that will be the x and self dot y. This self x and y is basically the position for the bird, and similarly we'll have the bird dot width, and similarly bird dot height of the bird. So these are the 4 criteria that will make the rectangle, and we have now completed our bird class. So let's quickly revise what we have done here. So inside this we firstly have this init function. So in this init function we just initialize all of the required parameters, and inside this update we'll just check on the basis of this delta frame, which is the number of frame elapsed. And now after that we'll just create the image property, which will be just checking on this based on this text, and if the text is modulus of basically 500, here a complete width and complete height, basically not width, it's complete height is greater or equal to 250, just return wings of, that is this image which has been masked. And similarly else just return this image, and it should be marks basically from this function. We have here a marks property, here there is a marks property, and similarly we have this rectangle to make the rectangle based on these 4 parameters that we passed. So this much for now. In the next lecture we'll deal with the pipes and we'll run our game. So see you there.